Hey everyone! Welcome back to Education is Life, your go-to channel for unlocking the wonders of learning. It is me, Joe Edgo, and today we're diving into Lesson 9 of the Arduino Uno R4 Minima Ultimate Training Series, focusing on creating user-defined functions and serial input. For today's lesson, you'll learn different ways to change the color of the RGB LED dynamically, such as reading user input from the Arduino serial monitor, and mapping the potentiometer's analogRead value to change the individual LED colors of red, green, and blue hues to produce any color we want. At the end of this lesson, you'll perform a challenge activity that allows you to choose between two modes of operation for changing the color of the RGB LED. In the serial input, typing 1 would go into manual mode where the user will use 3 potentiometers to manually set the red, green, and blue LEDs. On the other hand, typing 2 would go into automatic mode where the Arduino program automatically changes the RGB color continuously. Finally, typing 0 would reset the operation and the RGB LED turns off. Throughout this activity, you'll learn the foundation of writing efficient Arduino codes that are reusable, flexible, and easy to maintain with user-defined functions. As always, before we start, I'd like to extend my sincere gratitude to SunFounder for sponsoring this course and enabling everyone, especially beginners, to embark on this comprehensive educational adventure. Also, if you're new to this channel, I want to let you know that I am using the SunFounder Arduino Uno R4 Minima Ultimate Sensor Kit for all my video lessons throughout this series. This is such a great tool to learn the new Arduino Uno R4. This kit includes a lot of sensors that we are going to use for our future IoT projects. So if you're still looking for Arduino Learning Kit, I encourage you to please check this one out. This is available on the SunFounder website as well as on Amazon. The links are provided below. And now, let's begin. For this session, you need the following materials: a common cathode RGB LED module, and 3 pieces 1 kΩ current limiting resistor. You'll also need 3 potentiometers. You can use any type, or you can use the SunFounder rotation sensor if you have one. Of course, a breadboard, some connecting wires, and your Arduino Uno R4 Minima. In our previous lesson, you learned how to control RGB LEDs through pulse width modulation. You also learn how to produce a glowing and fading effect on RGB LEDs. And finally, you were able to produce a variety of colors by mixing the red, green, and blue hues. If you want to review this lesson, I provided the link below. Now, to understand the concept of creating custom functions, let's work with the same sketch that we wrote last time. Recall that we defined 3 macros for the red, green, and blue pins. And then, every time we want to produce a mixture of colors, like this one for example, we call the analogRead function 3 times to set the individual values of the red, green, and blue LEDs to produce a purple light. Same with this to produce a teal color, and this one to produce gold. Now, in Arduino C programming, we create user-defined functions or custom functions to organize and modularize our code. There are 4 types of user-defined functions that we can create, and you're gonna learn 2 of them today. First is a function with no parameters and no return value. To illustrate this, in our sketch, I can cut these 3 lines of code, and I'm going to put them in a separate code block. So just underneath the loop function, I will create my custom function, and I will call it change to purple, and then paste the codes inside. Now, when I define this function, I put a keyword void before the function name. This void keyword specifies that this function doesn't return a value. It means that whenever this function name is called anywhere in our program, for example, I'll call it here, the program flow or control is redirected to this function, and this code block gets executed, meaning it performs something. Like in this case, it should change the RGB color to purple. And after that, when the code reaches the end of the function, the control is returned to the calling program. to continue the execution of the remaining codes. So this keyword void simply indicates that this function, change to purple, simply performs something, but after executing the code, it does not return anything to the calling program. And this is the simplest type of function that we can create, a function with no parameters and no return value. We can create as many functions as we want to start organizing our code. Like for these two other colors of teal and gold, we can create our custom functions as well. So I'll create void change to teal and then cut this and paste it here. Similarly, I'll create another function, void change to gold, and then cut this code and paste it here. So now, every time we want to change the color to teal, I'll simply call this function change to teal. Similarly, I'll call this function change to gold. Of course, this should work exactly as before, and to verify that, let's upload the code and see if it works. And it works exactly as before. So, a function is simply a name block of code that performs a specific task. In most object-oriented programming languages like Java or C#, this is called method. The first reason why we need to create a function is modularity. This allows us to break down large programs into smaller and more manageable parts, making the program easier to understand, maintain, and debug. Another reason is reusability, meaning once a function is defined, it can be reused in different parts of the program. This saves time in coding by avoiding the need to rewrite the same code multiple times. For example, I'll create another function that turns off the RGB LED. I'll call it turn off. So I'll set the red, green, and blue to 0. Now, if I want the RGB LED to turn off for 1 second before displaying another color, I can simply call this function here, and then delay for 1 second, and then as well as here, and here. So let's upload the code and see what happens. And it works as expected. Now, talking about reusability, we can still improve our custom functions here because, as you can see, these 4 functions are a bit similar to one another. They contain almost the same code, only vary slightly with the values of RGB to produce different colors. Now, imagine what if you need to produce 100 different colors? Are you going to create 100 different functions as well? With that, I'll introduce you to the second type of function that you can create. Function with parameters and no return value. So, instead of having several functions that perform similarly, I'll just create one function that can accomplish changing the RGB LED color depending on what the calling program wants. How do we do it then? I'll remove these 3 other functions and retain just one because they all look the same, except for the values being passed to this analogRead function. Also, I'll change the name of this function and make it more generic, like setColor. Now, instead of having a fixed value here for the red, green, and blue, why not replace this with variables so that we can set the color dynamically? So, I'll use variables R, G, and B. Of course, this is not going to work yet because we have not declared these variables in our program. Now, this is very important. What we want is that the calling program will decide what values will be used for these R, G, and B variables when this function is called, meaning the calling program will decide what color this function is going to make. And to make that happen, these variables R, G, and B must be declared inside this function parentheses as part of the function definition. And this is what you call a function parameter. A function can have one or more parameters. In this case, we're going to have three: int r, int g, and int b. When declaring multiple parameters, you must separate each variable with a comma. Also, make sure that you specify the data type for each. And now, in the calling program, when we call this function setColor, we are required to supply the values for these parameters. Please note that these values must be in correct sequence, as in values for the red, green, and blue. This is what you call argument. In this case, we have three arguments to supply. So, I'll pass 142, 51, and 163. In effect, this setColor function should produce a purple light. Now, to turn it off, I'll call this same setColor function and then pass 0, 0, and 0. And then, say I want the next color to be green, that is 0, 255, and 0. And then I'll just copy this code to turn off the LED. And finally, I'll set the color to cyan. That's 0, 255, and 255. And then turn off the LED again. Now, let's upload the code and see if it works. And it works as expected. So, creating functions with parameters allows you to create a more flexible and dynamic code. And speaking of flexibility and dynamic codes, what if you want your end user to specify or set the RGB values instead of these being hard-coded in your calling program? Then, that would be great. We no longer have to recompile and re-upload our sketch if we want a new color to be displayed. And to do that, I'll introduce you to serial input. First, I'll remove the rest of the codes here to make it more readable. Now, the serial monitor tool is a really great tool for debugging and establishing communication between a computer and an Arduino. Aside from the usual thing that we do here, where we send data from an Arduino to computer using the print function, we can also use the serial monitor to enter data in the input field to send values to the Arduino. Actually, any serial program or even custom serial application can be used to send data to the Arduino using the serial communication protocol. The idea is that we can check if there are available bytes of data that we can read from our serial port. For that, we will be using the Serial.available function. This function gets or returns the number of bytes or characters that are ready or available for reading from the serial port. The serial buffer can hold up to 64 bytes. Now please note that one character is equal to 1 byte, meaning if we're going to use this serial monitor to send character data to the Arduino board, we will be typing it here through this input text box. So, we need to check if the available number of bytes or characters is greater than 0, meaning there's an available number of bytes to read. If so, we can start reading the bytes. Now, this serial.read function returns an integer type of the first byte of the incoming serial data available. For example, I'll declare a variable int incoming data, and then I'll use it to store the return value of this serial.read function. And after that, I'll print it to the serial monitor, utype, and followed by the actual character, just to verify. Let's upload the code and test our program. Now, in this input text box, say I'll type Joed. And once I hit the enter key, we can see 4 different numbers printed on the screen. You typed 74, you typed 79, you typed 69, and you typed 68. So, why 74, 79, 69, and 68? Actually, Any character, number, or symbol that you type here will be converted to its equivalent binary code that your Arduino board, your computer, or any digital device can understand. This is called ASCII, which stands for American Standard Code for Information Interchange. It is a 7-bit code where each bit combination represents a unique character. Then later, the extended ASCII character set uses 8 bits to accommodate 256 characters and symbols. Now, in this table, we can verify that the capital character J has an ASCII code of 01001010, and it is equal to 74 in decimal. Capital 0 is equal to 79, while capital E is 69 and capital letter D is 68. And that's the reason why we're getting these numbers when we print the values we read from the serial input. Now, the reason why it is printed one by one is that the Serial.read function only reads and returns one character at a time. And every time our code execution loops back, it checks if there are still available bytes of characters to read. Since we have 4 characters available, this code block executes 4 times and prints these 4 ASCII values in sequence. Now, what if we want to send a set of values for our red, green, and blue colors so that we can dynamically change the color of this RGB LED through the serial input? For example, if I want magenta, can I just simply type here a comma-separated values of 255, 0, and 255? Notice that as soon as I hit the Enter key, all the ASCII equivalent bytes of characters get printed on the serial monitor one by one. These are the equivalent ASCII codes for 255, comma, space, 0, comma, space, 255. Although this works, this is not exactly what we want. The Serial.read function is very useful when reading individual bytes of data from the serial port. And if we're going to use this function, we need to perform additional steps or algorithms to join or concatenate these characters when reading this entire array of characters to form a string. And then slice them to get the first whole number, 255, to represent red, and then the second whole number, 0, to represent green, and the third whole number, 255, to represent blue. Although we can do that, I'll introduce you to another function called Serial.read string until. The read string until function also reads characters from the serial buffer, but instead of returning a single byte of character, it returns a string of characters. Now, this function requires a parameter of character type called terminator. So, what's the purpose of this? This parameter is any character symbol that, once seen in the serial buffer, denotes the end of that string and returns that string to the calling program. Note that the terminator character is discarded from the serial buffer and will not be included in the return string value. It means that if I type 255, 0, 255, I can use the comma symbol as the terminator character, so that when this symbol is encountered, it returns all the characters before this comma symbol as a single string value. For example, 255 is returned as a single string value upon reaching this comma. And then, space 0 is returned for the second call to this read string until. And then, space 255 for the third call to this function. Now, before I compile, I need to change this incoming data from int to string type. Please take note that S here is in capital. So let's upload the code and see what happens. Now, when I enter 255, space 0, space 255, we were able to slice 3 string values out of this array of characters. And now, our next step is to pass these 3 string values as an argument to the R, G, and B parameters of our setColor function, but it has to be of type int instead of type string. Now, aside from that, we have another anticipated issue here. If we type more than 3 comma-separated values, for example, I'll type 123, 90, 56, and 255, in this case I have 4, then our program will also return and process 4 numbers. So, to resolve this, first I need to create 4 variables. The first one is a counter variable, and I'll initialize it to 0. And the other 3 variables will hold the integer values for the red, green, and blue. Now, inside the loop function, if there's an available data to read, I'll also check if the counter is equal to 0. If it is true, I'll read the first string until a comma symbol is encountered. Then, I'll use the toInt function to convert the string value to integer data type. One more thing, instead of using this string incoming data, I'll use this R variable to hold this first value. And then I'll duplicate this code and change this to else if, and check if counter is equal to 1. And if so, it means that I'll be reading the second string and then convert it to int and then store the result to the G variable. Again, I'll duplicate this code one last time and change this counter is equal to 2 and store the result to B variable. Now, the key here is, of course, to increment this counter by 1 after every successful string read, so that when the program loops back, it checks if there are still available data to read, and if there are, it checks the counter so that it knows where to store the next color value. In addition, I'm going to add another if condition here that checks if the counter reaches 3. If this turns out to be true, it means that we already have the values for R, G, and B. And if so, if the user types in more than 3 comma-separated values, I will discard the rest of the characters by calling one last time the readStringUntil function. But this time, the terminator character I'll use is the \n, meaning a new line of character. This means that I'll discard all the characters until the enter key has been pressed. Then, I'll reset the counter variable to 0. And then, I'll display the individual values of the R, G, and B variables. Now, I'll upload the code and see if it works. So, if I type 255, 0, 255 and press enter, and it works. Let's try another one. And it works perfectly. Now, let's test what happens if I enter more than 3 values. And it still works as expected. Now, the only thing to do is to call the setColor function and pass in these 3 variables R, G, and B. Also, I'll get rid of this. And then I'll upload the code and test it one more time. So let's see. I'll test 255, 0, 0. And we were able to produce red. Good. I'll test magenta. That's 255, 0, 255. And it works great. One last time, I'll get it from the RGB color picker. And this works perfectly. You can also control how to change the color of this RGB LED using analog inputs. Instead of typing the values of R, G, and B colors using the serial input, we can use 3 potentiometers to independently control the red, green, and blue hues to produce a variety of colors. Let's implement this circuit diagram. Please note that you can use any type of potentiometer, and if you want to refresh your memory on how potentiometers work, please check out the Lesson 6 of this course. I provided the link below. Now, in our sketch, we're not gonna be needing a bunch of codes here, so we no longer need this incoming data and counter variable. I'll also remove this entire if block. Now, if you recall, when reading analog inputs, the default ADC resolution of Arduino Uno R4 is 10-bit. This will give us a range of numbers from 0 to 1023. However, each color in the RGB model is only 8-bit depth, requiring a range of values from 0 to 255. So, the simplest solution is to set the analogRead resolution down to 8 bits. And as simple as that, we can use the analogRead function to read the red ADC value from A2 and store it in the R variable. The same goes for the green at A1 and the blue ADC value at A0. Then we can also print the RGB values on the serial monitor. And of course, we need to call our setColor function and then send these RGB values as arguments. I'll also add a short delay here before looping back. So now, let's upload the code and verify the results. So now, we can see in our serial monitor the RGB values being received from the 3 potentiometers. And as I turn the red potentiometer clockwise, we can see the RGB LED producing a red color. And as I increase the green LED, we can see a touch of orange and yellow. Now, I'll reduce the red, and we are seeing a much solid green color. And then, adding blue to it produces a touch of cyan. Now, as I reduce the green color, the LED turns to a more solid blue. And then, adding red to it produces a shade of purple to magenta. And finally, reducing the blue would turn the color to pink and eventually turns back to solid red. We can play around with it and observe up to 16.77 million possible color combinations of lights. That's actually 8 times 8 times 8, which gives us 24-bit depth of RGB colors. So 2 raised to 24 gives us 16.77 million combinations. And now, for your challenge activity, I want you to improve this program to allow users to choose between 2 modes of operation for changing the color of the RGB LED. In the serial input, typing 1 would go into manual mode, where the user will use 3 potentiometers to manually set the red, green, and blue LED colors. On the other hand, typing 2 would go into automatic mode, where the Arduino program automatically changes the RGB color continuously. And finally, typing 0 would reset the operation and the RGB LED turns off. Again, thank you so much for joining me in this lesson on user-defined functions and serial input in controlling RGB LEDs. For our next lesson, we'll talk about arrays and understand its importance in Arduino C programming. If you found this lesson enlightening, don't forget to hit the like button, subscribe for more knowledge pack sessions, and ring the bell to stay updated. So, keep learning, keep experimenting, and always remember, education is life. See you in our next lesson. Happy coding!